Greetings! Today we will talk to you about our naked mole rat trap design and demonstrate part of our working prototype. The motivation for this project is to assist Dr. Stanton Browdy of the WashU Biology Department in building a more effective and efficient naked mole rat trap. Professor Browdy has been trapping these animals in Kenya and Ethiopia for nearly 30 years, studying the birth, mortality, and exit rates from a number of naked mole rat colonies. Professor Browdy has built his own trap design, which he currently uses in the field, but is seeking ideas to improve his trapping ability. These improvements include an improved locking mechanism for keeping the shutter closed when a naked mole rat is trapped, a dust cap to keep debris out of the shutter chamber, and a remote detection system that will signal Dr. Browdy when a naked mole rat enters the trap. Our naked mole rat trap will improve on the design of Dr. Browdy by 1. Improving the success rate of the shutter's locking mechanism to above 95%, 2. Reducing dust and preventing any particles larger than a grain of sand from clogging the mechanism, and 3. Allowing detection when the trap is blocked by soil at least 95% of the time. These new capabilities hope to increase mole rat trapping success rate, speed, and ease of use in the field, while simultaneously providing a repeatable design at minimal cost.
For our design, we used the code and standard for live animal, specifically mammal, traps, ISO 10990. This standard provides test methods for performance evaluation of traps in the areas of animal welfare, capture efficiency, selectivity, and user safety. We reviewed this particular standard along with all of our trap design enhancements and alterations with Dr. Browdy and concluded that our design is compliant with the ISO 10990 because it humanely traps the naked mole rats without causing them any substantial physical harm in the process. The engineering analysis involved 3 tests to determine the force resulting from the shutter falling from a height of the trigger pin where it was released to the bottom of the main trap chamber. The first test involved releasing the shutter in free fall without any added weight or friction. The second test involved releasing the shutter with friction, which added resistance to the falling shutter and thus reducing the force on collision. The third test involved adding additional weight to the shutter. Many of the risks have been discovered through our discussions with Stanton Browdy. The greatest risk is associated with the designing a device to detect the soil blockage in the trap. Any electronics or cameras require a power source and are sensitive to the rough environmental conditions, thereby increasing the likelihood of failure. Another risk is improving upon the locking mechanism, which is already relatively effective. Our new design must improve the locking success rate while maintaining the simplicity and repeatability along with reducing costs. The device mechanisms are also subject to difficult environmental conditions and wear as they are buried in the ground. The engineering analysis in combination with our discussions with Dr. Browdy suggests that the current design, even with the small amount of weight added, should be successful in capturing the naked mole rats with little risk of harming them. However, the design should be further optimized to reduce the amount of friction between the shutter and the internal wall of the shaft.
I'm here with Drew and Adam to demonstrate the working prototype. Here we have a shutter door which will fall in place trapping any naked mole rats inside, and a locking mechanism consisting of a spring-loaded pin which will lock the shutter door in place.
We'll go ahead and pull the trigger pin.
As you can see, the rat isn't going anywhere.
While our existing prototype is functional, there are a number of improvements we plan to pursue. One issue we experienced was the shutter not being able to fall under its own weight due to the resistance force applied by the locking pin. To combat this difficulty, we added a small piece of stainless steel to the top of the shutter, but would ideally like to remove that load for both aesthetic purposes and to limit the chances of harming a naked mole rat. We are planning on both 3D printing the shutter with a higher resolution and also sanding it to remove impurities on its surface. Additionally, we are going to round the head of the pin using a lathe to reduce the surface area of contact resistance. Our final product, which we will present to Dr. Browdy at the end of the semester, will include the aforementioned locking mechanism, a dust cap to sit on top of the shaft, and a remote detection system as well. Our next step is to implement the remote detection system into our working prototype. We ordered and received an IR sensor, an Arduino, battery supply, connection cables, and a Bluetooth shield. We will be working in the coming days to program the Arduino and integrate this system into our existing design. We will also refine our locking mechanism per the various prototype upgrades I just discussed. Additionally, Professor Braude has asked us to 3D print him 10 copies of our functional locking mechanism design so that they can be fixed to his existing trap and used in the field when he travels to Eastern Africa next May.